In NumPy, what does the array.reshape method do and why would you want to use this? Let's find out in this lecture. In this lecture, we'll see how we can implement linear regression in TensorFlow, working on some real world data. We'll work on the stock picker data that we downloaded in the earlier lecture. We'll use this regression to model how changes in the S&P 500 index affects Google's stock price. So the cause is the value of the S&P 500 index and the effect is Google's stock price. As a very first step, we'll set up a baseline in Python for our TensorFlow regression model. Linear regression is a standard numerical problem, and there are a ton of Python libraries which implement this. We'll implement linear regression in Python, get a set of results, and then implement the same thing in TensorFlow. The baseline will serve as a comparison for how well our TensorFlow regression model does. If you're using Cloud Shell to connect to Data Lab, it's possible that your Cloud Shell session has expired. In that case, you need to reconnect, and you can do that using Data Lab Connect and the name of your Data Lab instance, which in our case is TensorFlow. Open up port 8081, and there you have it. Your Data Lab instance is still alive and well. We are currently working in the Data Lab /learning TensorFlow folder. Create a new folder in here called data, and this is where we'll store the CSV files that we downloaded from Yahoo Finance. This is the data that we'll use in our regression models. Go ahead and upload the CSV files that you have on your machine onto this data folder within your Data Lab VM instance. As you can see, I have very indicative names for each of my CSV files. I know exactly what data each of them represents. All the sample code that you're going to see in the next few demos is present right here in this Learning TensorFlow folder. In this lecture, open up the file for linear regression with stock market data. That's what we'll be using now. All our code will extensively use these two libraries in addition to TensorFlow, Pandas and NumPy. Pandas is a great tool for manipulating data in a tabular format, and NumPy is the standard Python tool for numerical computations. There are a bunch of helper functions that we'll use to read in data from the CSV files and set up and format the data the way we want it to be. You'll find these helper functions in the first few code cells of every IPython notebook. If we use these helper functions, I'll explain what exactly they do and how we format the data. Let's look at the very first one, read Google SP500 data frame. This reads in data for Google as well as the S&P 500 from our CSV files. The return value for this function is a single data frame which contains the returns for both Google and the S&P 500 for the same range of dates. The columns in the data frame are date, Google's returns, and the S&P 500's returns. Store the path to where your CSV files live in the Goog file and SP file variables. In our case, they are both in the data directory under the current working directory. We use pandas to read in both of these CSV files. We specify the path to the file, fields within individual lines are separated by a comma. The only columns that we're interested in for both these files are columns 0 and columns 5. Column 0 holds the date and column 5 holds the adjusted close for Google as well as the S&P 500. We give these columns simple names such as date and Goog for the Google file and date and SP500 for the S&P 500 file. We also want to include the headers that are present for these columns, which is why header is equal to 0 in our parameters to read CSV. We want to merge the data from these two data frames into one single data frame, that is the Goog data frame. We set up a new column called SP500 in the Goog data frame and assign it the values from the SP500 column in the SP data frame. This operation is effectively a join on the date column. All the adjusted close values for both Google and the S&P 500 will line up on the same date. In all our regression models, we'll work with returns data. What is the percentage return that we get month over month for Google as well as the S&P 500? We need to convert these adjusted close values to returns, and to do that, we first need to sort by date. And in order to sort by date, Date should not be expressed as a string field, it should be of type date. Use the toDateTime method in pandas to convert our string date to the format that you see on screen, that we assign to the date column in our single data frame. The next step is to sort the data frame in the ascending order of dates. This you can do by calling the sort values function on the Goog data frame. Once the data frame is sorted in the ascending order of dates, you can use a very handy function that data frames offer in order to calculate returns. This function is percentage change pct underscore change. This method automatically calculates the percentage changes on adjacent cells in a data frame. We only want to apply this percentage change method to those columns that are of numeric types. We don't want to apply it to the date column that's present in our data frame, which is why we iterate over the column data types for each column in this data frame and apply the percentage change method to those columns which are either float 64 or int 64 types. That means returns will be calculated for our adjusted close columns. We store this result in a data frame named returns and return this data frame from this method. The next helper method that you see on screen is not something that we'll be using right now. So let's skip over the explanation for read Goog SP500 logistic data. We'll come back to this when we perform logistic regression. The method after that, the helper method that we will use in this demo, is the read Goog SP500 data. This is the method that sets up the x and y values that are required to train our linear regression model. The return value from this method is a tuple with two fields. The first field has the returns for Google and the second field has the returns for the S&P 500. Each of these fields are represented as one-dimensional arrays. In the first step, we call the helper method that we just saw, read Goog SP500 data frame, and get a data frame called returns. This contains the date column and returns for Google as well as the S&P 500. From this data frame, extract two one-dimensional arrays. One array which is X data, which contains all the S&P 500 returns, that forms the X-axis data for our linear regression. And the second array is Y data, which contains the returns for Google stock. Both of these returns data sets, we filter out the very first row. That's because when we go from prices to returns, we always have one less data point than we started off with. The very first day for which we have the adjusted close will have no corresponding value for returns. We filter out the very first row as shown by the example on the very right of the screen. Return a tuple from this function which contains both of these arrays. There is another helper function here, read exom oil NASDAQ data. We look at this later when we actually use it while performing multiple regression. Once we've understood the helper functions that we're going to use, we are now ready to set up the baseline implementation of linear regression. We'll perform this baseline computation using a library called scikit-learn. So from sklearn, we import datasets and linear model. Scikit-learn is a very powerful Python library for numerical computations. It's very popular and widely used. That's what we're going to use here to set up our baseline. The first step is to get the x values and y values that will be part of our linear regression. This we do by using the helper method that we set up earlier, read Goog SP500 data. Performing linear regression in scikit-learn is very easy. We simply use the linear model library and instantiate a linear regression model and assign it to our Goog model variable. The next step is to fit this model on the data that we have, our x data and y data. All of this is very straightforward. The only thing that might be slightly strange here is the reshape method that we call on x data as well as y data. Let's understand why this is. If you think about linear regression conceptually, it involves passing in x and y variables to our regression algorithm or our regression model. And the output of this model, given these x and y values, is the equation of a line. This is the conceptual setup. When we want to implement this regression in a practical way using existing libraries, we have to set up the data in the way that the library expects the data to be. Python libraries expect that the input data will be in the form of arrays. In particular, the X data for our linear regression should be in the form of an array of arrays. We can achieve this very easily in NumPy by using the reshape functionality. Reshaping a single dimensional array in NumPy with -1, 1 will give us an array of arrays where every element in the original array is enclosed in a single element array, and these single element arrays live within a larger array. Once you fit the regression model set up in scikit-learn to our X data and our Y data, that is their reshaped values, all that's left is to print out the coefficient and intercept of this linear model. The value of the slope parameter or the coefficient is 1.0676, and the value of the intercept is 0.00846. This sets up our non-TensorFlow baseline, and any TensorFlow implementation that we have for linear regression, we'll compare with this to see how they differ. The reshape method on NumPy arrays allows us to change the shape and dimensions of any array. If you have a library that requires your arrays to be of a specific shape or a specific dimension, you can reshape your existing data to fit the needs of that library.